This is section 2.4. We're going to talk about writing fractions in lowest terms. Oops, sorry. We talked about prime factorization and factors in a previous section, and so we are building on that. So if you didn't watch that video and you don't understand that very well, you need to make sure you start there. All right, so let's look at the example we have on the screen here. And it says, when working problems involving fractions, we must compare two fractions to determine, whether, I can't type and make it make sense here. Whether they represent the same portion of a whole. Look at the two cakes. So imagine that these are cakes that I have made here. The first one, which is the one on the left, if we were to count up all of the pieces, I would find 1, 2, 3, 4, 5, 6, 7, 8 on the top, so 8 on the bottom, so that makes 16 pieces total. On the right side, I count them all up and I end up with 4 pieces. If I count the shaded parts in my left cake, I get 8 across the top, 9 here, 10, 11, and 12, so this becomes 12. And on the right side, if I count these up, I get 1, 2, and 3. So the two fractions I'm comparing here is the 12/16 and the 3/4. I know that these two are identical fractions because of the pictures I look at. I know that if I took one of these pieces and laid it on top of the other one, and let me see if I can actually do that here with group these together well enough to help you make this make sense. If I drug this fraction on top of the other one, you're seeing that they are, sorry, I don't know what I have going on here. I have identical pieces. You can see that the shaded parts sit on top of each other perfectly, and so I know that 12/16 and 3/4 are matching pieces here. How else could I compare these? Well, I could do something where I multiply across in the diagonals to compare them, and I'll show you that in just a little bit. Or we could simplify them and put them in lowest terms, and if I kept dividing the top and bottom by the same number, I would end up with 3/4. So again, I'll show you those examples in just a second, but I want you to see that picture-wise, we can identify if they're equal by a picture. So here is the definitions for equivalent fractions. Equivalent means the same. Are they matching? So two fractions that represent the same portion of a whole, so matching fractions. And common factors is a number that divides evenly into the numerator and denominator of a fraction. Lowest terms means a fraction that has no common factors. So let's talk about what this looks like. If I have the fraction 3/4, I can't find anything to divide into 3 and 4, right? I have to pick the same number because that's what a common factor would be, besides 1. Because how did I get 3? 1 times 3. And how did I get 4? 1 times 4, or 2 times 2. But 2 and 1 and 4 do not go evenly into 3, so I can't choose any of those numbers. And notice that when I divide by 1, it doesn't change anything. So I know that 3/4 is in lowest terms because they have no common factors. Okay, let's look at 12/16. What numbers divide evenly into 12 and 16? There's actually a couple, but we're going to start with 2. Why? Because it's easier to find a small number. Okay, I know that 2 goes into both of them evenly because they're both even numbers. So when I do this, I end up with 6/8. Why? Because 2 times 6 gave me 12 and 2 times 8 gave me 16. I know that 6 and 8 can both be divided by 2. Why? Because they're both even numbers. And so when I get this answer, I end up with 3/4. Can 3 and 4, 3/4, be simplified any further? We already know the answer is no because we just tried this problem a second ago. So I know that equivalent fractions, meaning matching fractions, are 12/16 and 3/4 because I went through this process right here. But I also know that there are common factors of 2 and 2, which is actually 4, that go into this 12 and 16 evenly. Okay? So this is the process over here that we go through to put our fraction in lowest terms. Okay, let's try another one. Are 3/8 in lowest terms? Yes, because the only numbers that go evenly into 3 are 1 and 3. The only numbers that go into 8 are 1, 2, 4, and 8. And they don't have anything in common besides 1, right? This is a really bad 8. I apologize. There's your 8. So if there was another number, then we would have what we call a common factor. 1 is a common factor, but 1 doesn't change anything when we divide by it. So that means that 3/8 is in lowest terms. Good. So let's try another one. 21 over 36. Remember I need to find the factors. So the factors of 21 are 1, 3, 7, and 21. The factors of 36, 1, 2, 3, 4, 6. Sorry, getting crazy here. 9, 12, and 18. And 36, I apologize. So I'm looking for, is there a number that matches in that top row of numbers and the bottom row of numbers? This one does, and this one does. Remember we said earlier that the 1s aren't going to change anything, so the 3s are what I have in common. So I'm going to take 21 over 36 and divide them both by 3. You can only simplify or put them in lowest terms if you were applying the same thing to both of them. So I have to divide the top number and the bottom number, numerator and denominator, by the same number. So we're dividing by 3. And so when I do that, I end up with what? 7 over 12. Because 3 times 7 is 21 and 3 times 12 is 36. So 7/12 is our final answer. All right, in this next part, we're not just finding factors like this, where we see them here and here. We're going to find prime factors because we have to find prime factorization to help us reduce or simplify. So here's our problem, 24 over 42. I need to write out all of the prime factors of 24 and all of them of 42. So that would be 2 times 12, where this is prime, 2 times 6, where 2 is prime, and 3 times 2, where those are both prime. So this became 2 to the 3rd power times 3, or 2 times 2 times 2 times 3. In this case, I'm going to use this one because I can see them all written out. The 42 is 2 times 21, and this is 7 times 3. Okay, so what I'm going to do here, and now I have 2, 3, and 7 for this one. All right, if you didn't get these, write it down and come back to it, or pause the video and write them down, and then you can start the video again. So I'm going to erase the work that I just did here so I can have some more space on the screen. Now, I'm going to show you that my numerator, my top number, 24, the prime factorization is 2 times 2 times 2 times 3, and the bottom is 2 times 3 times 7, okay, which makes me get rid of all this scratch work. What I now have is to simplify, and I see a 2 and a 2 that cancel out, and a 3 and a 3 that cancel out, and I'm left with 2 times 2 on top, which is 4, and 7 on the bottom, and so 4/7 is my final answer. So you can try to find the numbers that you can divide evenly into the top and bottom over here, which would be 6 in this case, to end up over here. Or you could use prime factorization, which are the trees that we did. The 24 branched out and the 42 branched out, and that's how we got all of these numbers. And notice when we got those, you can just mark them out with what matches, multiply what is left over, and bring over if there was any plain ones by themselves. So you can, depending on what the instructions ask for, you may have to perform those types of steps.